Mechanical resistance. This is Unit 4. Alright, friction. We're talking about friction. They describe it as dry friction when you have two surfaces that slide against one another. That's why, like in your car, you have to use oil, the lubricants. It helps to reduce the friction between the moving parts. Sometimes they refer to that as a wetting agent. Now, there are types of friction. All right. First of all, there's what's called the coefficient of friction, and that's how much friction you have at the atomic level between two surfaces. All right. And then the next part is that depending on the motion that you have what's called static friction. Now, if you look at this little symbol here, it looks like a funny looking U. It's actually the Greek letter mu. And it stands for coefficient of friction, and it tells you what type. And the S stands for static, which means that it's not moving. And then the next type is kinetic. Right? Think of kinetic energy, energy of motion, means that it is sliding. So UK, that's sliding. And then you have another one that you don't always see in physics books. It's UR. And the R stands for rolling. That means like if something has wheels on it. So basically what you have are the three kinds. You have static, which means just before it starts to move. In other words, it's harder to move something when it's stationary and then you get it moving. But once you get it moving, it's easier to move, especially like if you're sliding something. Or why do you think they put wheels on things? Or if you're going to move something heavy, they use a hand cart, or they have little caster wheels that they put underneath them. All right, that's so that you are going to be reducing the friction. Okay, with the static friction, also called stationary friction, and as I said before, it's just before you move the object. All right, and static friction of all the frictions, that's the highest. All right, and again, what is coefficient of static friction? It's the ratio between two surfaces just before the object moves. All right, what about kinetic friction? All right, it is sliding friction, and it's the ratio between two surfaces. Like we have a picture here of a little girl on a slide. That is the friction that you have between her, all right, and the slide. I don't know if you've ever done this when you were younger, when you're on a slide, but I remember as a kid that we used to have metal slides, and you could change the coefficient of friction, of sliding friction, by sitting on wax paper when you went down the slide. And what it did is it waxed it, and so what happened is you had actually reduced the friction. All right, so you actually change at an atomic level. You filled in those little gaps and things that actually cause you to have a rough surface. So you're actually, as kids, we didn't realize it, but we were changing sliding friction. Okay, and then we have rolling friction. All right, and the little guy as he wheels the hand truck across the screen there. Basically, what you have there is, all right, he's got the wheels on the hand cart. All right. And again, it's the ratio between two surfaces when an object is rolling. And this is always the lowest friction. This is one of the reasons that we use hand carts. And you have, well, now it's very common that on your luggage you have wheels to make it easier to pull through airports. All right. Now, if you were to take a crate, all right, and there is, so you can assume that there's a table. It's not just hanging there in the air. You're going to have the weight of the object is going to be downward. This is what's called a force diagram. Some books will call it a free body diagram. You start at the middle of the object, and what you're basically going to do is you're going to show all the forces that you have on it. Now, forces always act in pairs, and the pair that you're talking nearly about are pairs that are going to be in opposite direction, because you have to be able to describe them as balanced or unbalanced. Okay, now if this object is just sitting on a table, the weight is going downward, then it's going to have a force that's equal and opposite if it's not moving. All right, it's just sitting there. All right, not going through the table, it's not levitating up from the table. These two forces have to be equal but opposite. All right, now it's these forces. If you're pushing that crate on table, effort force is what you're putting in. All right, so you're pushing it that way. It always has a resistance, which is going to be your force of friction. All right, now if these are equal, then the object is not moving. You haven't put enough force, effort force into it to move it. You have to put in more effort force if you wish to move an object. All right, meanwhile, these two remain the same. So in this direction here, back to an old word that we used to use, all right, in the beginning of the year, these would be balanced. All right, it's not moving in the vertical direction. And here, if the object is moving, it is unbalanced. Okay, and one other thing to add to our picture here is your coefficient of friction is going to be actually an interaction between the surface of the crate and this surface that you're pushing the box on. Okay, now, how much friction? What determines that? First of all, this first one, how rough is the surface? I was telling you about the wax paper on the metal slide. All right, how rough are the surfaces? That's where the coefficient comes from. And then the other thing is the weight. All right, the normal force is equal to the weight. All right, when the force is applied parallel to the surface. What that basically means, as long as you're pushing the box, all right, and the force that you're applying is parallel to the surface that you're moving it on, they will be the same. Now, we won't get into more difficult problems. If you were taking the other physics course, we do get into that. But as soon as you start applying a force at an angle, that rule is no longer true. All right, let's take a look at our first equation. F stands for force, all right, and there's many kinds of forces. And when you have the subscript here, F, that means your force of friction. That's your resistance. This is your coefficient of friction, all right, and usually you want to identify what kind. That's where you use the S, the K, or the R. And then you have, this is called the normal force, that's F, with a subscript of N. And in these types of problems, what happens is the normal force is actually equivalent to the weight. Okay, so we went through our units here. And a couple things you need to know. Let's look over here at normal force. If you're dealing in English, it's going to be pounds, and the SI, it's going to be newtons. So anytime you see forces, that's typically what you're going to have. All right, but I want you to look here for the coefficient. Look, there's no unit. All right, that means that it's really, the coefficient of friction is actually a ratio, so they cancel each other out. The thing to remember here is that when you have forces, if you're in English, they're generally going to be measured in pounds. In SI, they're going to be measured in newtons. All right, here we have a chart of coefficients. And I want you to notice a couple things here is that, well, let's look at this one right here. All right, which one is the highest? It's the static. Okay, just before the object starts to move. It's less for the sliding and even less for the rolling. Okay, so that was like what I was telling you before, that when you see trends, this one should always be the higher one. Okay, what are the negative results of friction? All right, if you're thinking of a car engine, it's energy loss, it generates heat, which is waste heat, and it's a wear and tear on parts. If you don't think it's a wear and tear on parts, you should see what your oil looks like when you change it. All right, that's one of the reasons that it's all dark in color, and one of the reasons they tell you that you're not allowed to put it on roadways, because some of the parts, the types of metals that are used there would be poisonous to your drinking water. All right, an example here of friction. All right, a child starts to push a 100-pound wooden box with 75 pounds of force. What is the force of friction, and what is the net force? All right, let's first identify what we have here. The child starts to push. All right, so we're looking at static, coefficient of static friction. All right, 100-pound wooden box. That's the weight, so it's going to be equal to the normal force. And we're told that you push with 75 pounds of force. That would be your effort force, okay, or your applied force. What is the force of friction? All right, we're going to be using this equation right here. So if we look up a wooden box, all right, and let me see here, wooden box, let me move back to that, we have wood on wood. All right, so a wooden box on a wooden surface. Okay, that's where that's coming from. And it's static, so that was 0.7. Multiply that by 100 pounds, and that gives you 70 pounds. So you have a resistance of 70 pounds you have to overcome. So if you were to take your force of friction and you subtract your applied force, what's going to happen is that you're going to be left with 5 pounds of force. Okay, so it means it's moving. If they were equal, they wouldn't be moving. If your resistance was greater than your applied force, it wouldn't be moving either. All right, we have something else that we look at here is we don't call it resistance or friction, we call it drag. Whenever you have an object that's moving, a solid object, all right, moving through a fluid, they refer to it as drag. Like when the example here, we have our boats. All right, here are some pictures here of what happens when you start talking about aerodynamics. And here you just have this line here. And where you see the curls, all right, that's turbulence. So you can see like a flat object. You've got your wind coming this way, and you see all this turbulence. That is a lot of drag on the object. You make it a circle, all right. It's good here, all right, but you're still getting some turbulence. It's less than the previous picture, okay. What about if you make it kind of a circle with a tail on it? All right, it's better yet. You have less turbulence. And then look over here. Okay, doesn't that look like the wing of an airplane, doesn't it? All right, look at that. It's very streamlined, and you don't have the turbulence. And that's how, like when they make cars and they make airplanes, that you want them to be streamlined so they don't use as much gas and they don't have as much drag. If you click on this one here, there is a video of 1930s cars and how they streamline them. It's actually quite an interesting video. It would be an interesting thing to take a look at. All right, now the next one you have is drag resistance. All right, and that's drag force divided by the speed of the object. So with that one, all right, your resistance is R. The D is drag. All right, so drag resistance. This is your force. That's your drag force. And V is going to be speed. Force, again, is going to be pounds in English, newtons in SI. Miles per hour is in your velocity in English, and meters per second. All right, and it's just going to be pounds over your velocity, all right, miles per hour, and newtons over meters per second. An example here, drag force on a boat. This is the equation we're using here. All right, drag force on a boat is 50 newtons. So that's going to be this right here. While it is traveling at 5 meters per second, that's going to be that there. So 50 newtons divided by 5 meters per second is 10 newtons over meters per second. And then last here we have a picture of an airplane. And notice your forces that you have here. Downward is weight, upward is lift. So if you want to make sure the plane is staying steady, all right, same elevation, these would be the same. If you need to go up, the lift has to be greater. And then in the forward direction, you have thrust, and then opposite or resistance would be your drag. Okay, well that wraps up our mechanical resistance for right now. You have a worksheet that follows. Thank you. Have a good week.